We are now at question 3. Express 5 sine theta plus 12 cos theta in the form r sine theta plus alpha, where r is a positive value and alpha falls between 0 and 2 pi. So we have 5 sine theta plus 12 cos theta. We equate that to r sine theta plus alpha. So we can expand the right hand side. So just focus on the right hand side. So we have r and then the addition formula, sine theta cos alpha plus, and we alternate, sine alpha cos theta. And of course we can expand, distribute the r. So we have r sine theta cos alpha plus r sine alpha cos theta. And of course on the left hand side it's still 5 sine theta plus 12 cos theta. So we can now equate the coefficients for like terms. Alright, so equate coefficients for sine theta and cos theta. So let's do that. So for sine theta on the left hand side, the sine theta coefficient is 5. And on the right hand side, the sine theta coefficient, what's multiplied to it, that's r cos alpha. Let's equate coefficients now for the cos theta. For cos theta, on the left hand side, the coefficient is 12. And on the right hand side, cos theta, the coefficient is r sine alpha. So we can use this to find r and alpha. So what we can do here is that we can divide both sides. So we can divide, let's call this equation 1. Let's call this equation 2. So we can divide equation 1 by equation 2. So 12 divided by 5, that's 2.4. And r sine alpha divided by r cos alpha, the r will cancel r. So you're left with sine alpha divided by cos alpha, that's tan alpha. So tan alpha equal 2.4, which means that alpha is tan inverse 2.4, and we're asked to put the alpha in the answer in radians, between 0 and 2 pi, indicating alpha should be in radians. So put your calculator in radian mode, we end up with alpha tan inverse 2.4. That's 1 point, if I'm using 2 decimal places, that 1.18 radians, which means that that's alpha. And the value for r, so we can use again these two equations to get r. So we can square both equations. If we'll get 144. If we square this, we get r square equals sine square alpha. Square the left, the one below, equation 2. 5 square, that's 25, equal r square cos square. So square both sides in both equations. So we can add them. If we add these equations, 144 and 25, that's 169. That's 169 equal to r square sine alpha plus r square cos alpha. So we add these with r square sine alpha, well, r square sine square alpha plus r square cos square alpha. So the common factor there is r square. And when we sine square plus cos square, that's 1. So this is 169 equal r square. We take the square root of both sides. So r is equal to 13. And we already know that alpha is 1.18 radians. So this expression is the same thing as, so we can replace the r with 13. and the alpha with 1.18 radians. So alpha 1.18 radians. So in part B, we ask to hence or otherwise show that 5 sine theta plus 12 cos theta plus 7 is less than or equal to 20. One thing we could do is we can subtract 7 from both sides. So what we have is 5 sine theta plus 12 cos theta, and 7 take away 7, 0, and 20 take away 7, 13. Now, if you notice on the left hand side, this thing on the expression on the left hand side, we have just shown that 5 sine theta plus 12 cos theta is 5 sine theta plus 12 cos theta is this 13 sine theta plus 1.18 radians. So this is equal to 13 sine theta plus 1.18 radians. So we have just shown that the left hand side is that. We have shown this is less than or equal to 13. One thing we can do is divide both sides by 13. So we end up with sine theta plus 1.18 radians. So we divide both sides by 13. 1.18 radians is less than or equal to 1. So which is telling that the largest possible value for this is 1. The largest possible value for this is 1. So therefore, proven. Notice that sine theta, let's recall that sine theta, the maximum value we can have for sine theta is 1, and the smallest value we can have for sine is -1. Another way to look at it is to say, okay, this expression which we just shown here, the maximum value it can be is 13. It's always 13 or lower. So hence, the left hand side is always going to be equal to or less than 20. Let's move on. Show that 2 sin x plus 3 cos x is equal to 3 may be written as 13 cos square x minus 18 cos x plus 5 is equal to 0. So we have 2 sin x plus cos x plus 3 cos x equal to 3, and we have to use it to show that we'll end up there. So let me bring over the 3 cos x. So we have 2 sin x, and I bring that over, we'll actually have 3 minus 3 cos x. Alright, just simply bring the 2 sin x, the 3 cos x, sorry, on the right hand side here. And after that, now we can square both sides. So let's square both sides. So if we square both sides, we have the left hand side square with 4 sine square x, and the square means to multiply it by, so this is 3 minus 3 cos x times itself. So we end up with 4 sine square, and by the way, recall that cos square x plus sine square x is equal to 1, which means that sine square, if you bring this over, sine square is actually 1 minus cos square. So sine square can be replaced from this identity, the Pythagorean, with 1 minus cos square x. And if we expand the right hand side, the 3 times the 3, we get 9. 3 times minus 3, we get minus 9 cos x. And then minus 3 cos x times 3, that's minus 9 cos x again. And minus 3 times minus 3, that's positive 9 cos square x. And of course, we can seek to, let's expand this one on the left hand side here. So this is 4 minus 4 cos square x. And this is 9 minus 18 cos x. Two middle terms are the same. Plus 9 cos square x. So we can group everything on the one side now. So let's group everything on the right hand side. So let's group everything on the right hand side. So let me keep more space over here on the left. So we have 9 cos square. Bring over this negative 4 cos square. So we are with positive 4 cos square plus a 9 cos square. That's 13 cos square x. And we already have our minus 18 cos x. And then group this constant on the right hand side. We're not with 4 minus 9. That's positive 5. And to let it look like what we have there, we can just turn it around. So we're not with 13 cos square x minus 18 cos x plus 5 equals 0. And that's the proof. Hence, or otherwise, solve the equation 2 sin x plus 3 cos x is equal to 3 for x is between negative pi and positive pi, which is suggesting that the angle x should be given in radians. So we have just shown that 2 sin x plus 3 cos x equal to 3 can be written as 13 cos square minus 18 cos x plus 5. So let's rewrite this as 13 cos square x minus 18 cos x plus 5. So we have shown that this is an equivalent equation here. So we have a quadratic. So we can solve by factoring. So we need to split the middle term if I'm using the AC method to factorize. So it's obvious there we can use 13 and 5 minus 13 minus 5. These numbers add to give minus 18 and multiply to give the same thing as AC, right? Since A is 13 and C is 5. So 13 times 5 gives us the same thing as minus 13 times minus 5. Both of them give us positive 65, right? So we can factor by groups. So the first pair, we can factor out 13 cos x. So factor 13 cos x. We're left with cos x minus 1. Next, factor negative 5. We're left with the same cos x minus 1. So we have a common bracket there. So we can factorize. So cos x, it's a common bracket, minus 1 into 13 cos x minus 5. And we can equate both factors to 0. So cos x minus 1 equals 0, or 13 cos x minus 5 is equal to 0. Here it means that cos x is equal to 1, or bring over the 5 and divide by 13, cos x equal to 5 over 13. So the solution, x would be equal to cos inverse 1. If x equals to 0, so remember x should fall between pi r negative pi. Over here, x is cos inverse 5 over 13. Put your calculator in radians. So we get x equal to 1.18. And it doesn't matter if it's positive, right? So plus or minus 1.18 radians. Since it's allowed for x to be between 3.14 and negative 3.14 radians, then we can use positive 1.18 or negative 1.18. Part C is a proof. Show that 2 cos square x minus 1 all square over cos to the 4th power minus sin to the 4th power, we are asked to show is equal to 1 minus 2 sine square x. Let's try. So we start from whichever side have more terms. So let's start from the left hand side, LHS, abbreviating left hand side. So left hand side, is actually, notice is actually this cos 2x identity. 2 cos square x minus 1, that's same thing as cos 2x. So we're going to realize cos 2x in the bracket all square. So we know cos 2x equals several things. So cos 2x, let me just restate them here. We know cos 2x is 2 cos square x minus 1. We also know that cos 2x is equal to 1 minus 2 sine square x. And we also know that cos 2x is cos square x minus sine square x. Alright, so cos 2x equal to all these things. Alright, so the numerator is actually cos 2x, recognize that. Over now the denominator, notice that this is different as squares. Alright, so the denominator is actually the thing about the denominator is actually cos square square. Think of the denominator as cos square square minus sine square square. That's what the denominator is. So it's really a difference of two squares. Cos square all square minus sine square all square. So we can rewrite the denominator as cos square x minus sine square x into cos square x plus sine square x. So it's a difference of two squares. It should be a basic factorization. Alright? So that's our. Alright? What else can we do now? No, the numerator, cos 2x in the bracket. Cos 2x, an expression for cos 2x is actually cos square minus sine square. So we can rewrite the bracket as cos square x minus sine square x all square. Same expression for cos 2x. In the denominator, we have same difference as square, so cos square x minus sine square x over cos square x plus sine square x. And if you notice, what will happen now is that cos square minus sine square is 1 here, and there's 2 up here. So a cos square x minus sine square x up here would cancel this. So let me just write it out. Let me just write it out. So this is actually cos square x minus sine square x all square, and all square means you multiply it by itself, right? So times cos square x minus sine square x all over cos square x minus sine square x in the first bracket. Now in the other bracket, we should recognize that cos square plus sine square is 1. So this is 1. So times 1 down there. Alright, so that's 1. And then cos square minus sine square into itself. You're left with actually cos square x minus sine square x, which is the same thing as cos 2x. And of course, cos 2x, an expression for cos 2x is actually 1 minus 2 sine square x, which is what the right hand side is. The right hand side is 1 minus 2 sine square x. So that's a proof. So therefore proven. Question 4. A plane P passes through the point 5, 1, negative 3 and is perpendicular to the vector 3, 1, negative 4, plus 2. Show that the equation of a tangent is 3x minus 4y plus 2z minus 5 equal to 0. Alright, so equation of tangent, we have a formula for that. Equation of plane, not tangent. Equation of plane, the formula says r dot n equal to a dot n, where r is a standard xyz, n is a normal vector, and we're given n, which is 3, put it in column form, minus 4 and 2. A is a point in the plane, and we're told we're given a point here, 5, 1, minus 3, and of course repeat n, which is 3, negative 4, 2. So we're taking a dot product. So x times 3, that's 3x. Y times minus 4, that's minus 4y. Plus 2 times z, that's 2z. And then dot product, 5 times 3, that's 15. Plus 1 times 4, that's 4. Plus minus 3 times 2, no, well, I've made an error here. N is positive 2, not, this is positive 2, 3, negative 4, 2. So it's actually minus 3 times 2, that's minus 6. So we end up with 3x minus 4y plus 2z is equal to 15 plus 4, 20. Well, 15. So I made an error. This is a minus 4. So separate errors here. Alright, let's go again. So n is 3, negative 4, 2. So 3, negative 4, 2 here again. So 5 times 3, 15. 1 times minus 4, that's minus 4. And minus 3 times minus 2, that's minus 6. So it's actually 15 minus 4 minus 6. That's 5. That's 15 minus 10. That's actually 5. Which is the same thing as this. Notice if you should bring over the 5, you should bring over this 5, it's actually positive 5 on the right. So positive right on this there. So therefore, it's proven. Alright? Same thing. Calculate the angle in radians between P and the plane with the equation. So what was P again? P is a plane. Alright, so we're finding the equation between the angle between two planes. So P is this plane that we have just found, and we have another plane here, 7x minus 4y plus 3 is equal to 5. So let theta be angle between the planes. So cos theta is equal to the dot product of the vectors. So this plane is 7 minus 4, 3. That's a normal vector there. And the normal vector for the plane we just found is 3 minus 4, 2. So these are the two planes. At least a normal vector for them. 7 minus 4 and 3, positive 3. And the first one we found was 3, negative 4 and 2. All over the modulus. So all over the square root of 7 square, 4 square, plus 3 square, times the modulus of the other one is 3 square, plus 4 square, plus 2 square. And it doesn't matter if it's negative, because negative 4 all square is the same thing as positive 4 all square, 16. So cos theta, the dot product, would be 7 times 3, that's 21, plus 4 times 4, that's 16, 3 times 2, that's 6, all over the square root of the first one here, that's 7 square, that's 49, plus 16, plus 9, that's 74. And this is 9 plus 16 plus 4, that's 29. So this is equal to, so therefore cos theta is equal to, well, 21 and 16, that's 37. 37 and 6, that's 43. Over the square root, we can just, remember that root A times root B is root AB, so we can just multiply the two values there. So 74 times 29, that's 2146. The theta, which is the angle between the two planes, is cos inverse 43 over root 2146. And the angle should be in radians, so you put them out in radians. I'm using 2 decimal places, 0.38 radians. So 4b, the equation of a circle is given as x squared plus y squared minus 6x minus 8y minus 39 equal to 0. So the first thing we could do is maybe to find the center and the radius, we could just group the like terms. So we have x squared, group the x's together, we have minus 6x. We have y squared, and we have minus 8y. And then the 39, negative 39, group on the right hand side is positive 39. And now we need to complete the square, alright, for the x term separate from the y terms. So we form our square, x minus half of the b value. Form our square, it's always minus the square of the constant here. So minus 9. Do the same thing. Form our square. So it's y, follow the sign, minus half of the b, half of 8 there is 4. So always minus the square of 4, that's 16, equal to 39. And we bring all the constants on the one side, so we end up with x minus 3 all square plus y minus 4 all square equal to 39 plus 9 plus 9 plus 16. So that means x minus 3 all square plus y minus 4 all square, 39 plus 9, that's 48. 48 and 16, that's 64. So therefore, the center is whatever values makes the bracket 0. So for the x, it's positive 3. For the y, it's 4. And the right hand side, r square is the right hand side, the radius. So take square root of both sides, so r equal to 8 units. So the center is 3, 4. And the radius 8 units. Part 2, determine the equation of the tangent to the circle at the point 11, 4. Let me do a little sketch here. So I'll do a little sketch of the situation here. So we have a circle. We just found the center to be a little sketch. It's an ugly sketch, but it works. So the center is 3, 4. We just found that. And we're told that there's another point. There's another point, 11, 4. So if it's 3, 4, think about it. 11, 4 will be horizontal to the right, since both of them have the same y coordinate. So 11, 4, let's say our point 11, 4. So we have a tangent somewhere about there. So on this point, of course, we're told is 3, 4, right? 11, 4. Alright, so the radius will go from here, so the radius will be horizontal. That's the radius. It's a horizontal line, since the center and the point there where the tangent touches have the same y-axis. So it's a flat line. You should do a plot it in a graph paper. That's a flat line, a horizontal line that is. So the tangent would actually be fully vertical. So the tangent will just be the x-coordinate of the point there. So the tangent, the equation of tangent, the vertical line, so it's x equal to 11. Alright, and that's that. Part C, a point Q moves in the xy plane such that it is equidistant from A and B. Now, equidistance from A and B mean, of course, is a perpendicular bisector we're asked to find. The locus of Q. So if we think about it, let's do a little sketch. So let's say you have a point A. You have a point A. And you have another point. So A is the point 2, negative 5. And you have another point B. B is a point negative 2, positive 3. So here's your line. Here's your line segment connecting A and B. And now Q is always moving, so it's always from the same distance from B. So Q is always at the same distance from B. So Q, of course, the locus of Q would be in the direction. It's really the perpendicular bisector of AB. So the locus of Q will be this, the perpendicular bisector of AB. Since any point on this line is always equidistant from A and B. Always the same distance from A and from B. Alright, so we're really finding the locus is really the perpendicular bisector of AB. Now to find the perpendicular bisector of AB, we need to find the midpoint. So the midpoint of AB, let's write down the midpoint. We can simply write down the midpoint. The midpoint of AB, you simply just add the two x values. So if you look at AB, if you add these two x values, you get 0 divided by 2, that's 0. If you add the two y values, that's negative 5 plus positive 3, that's negative 2. Divided by 2, that's negative 1. So the midpoint is 0, negative 1. So the midpoint is actually on the y-axis. Alright, the midpoint will touch negative 1 on the vertical axis, on the y-axis. So we know for this equation, the c value will be negative 1. So we need to find now the gradient. Let's find the gradient of AB. So gradient of AB, perpendicular bisector. So gradient of AB, remember the formula for gradient, y2 minus y1 over x2 minus x1. So I'm going to call this x1, y1. I'm going to call this x2, y2. So y2 minus y1, that's 3. Take away negative 5. And x2, that's minus 2, minus 2. So this becomes positive 8 over negative 4, which is negative 2. Or negative 2 over 1, if you want to write it as a fraction. So therefore, AB has a gradient of negative 2. So therefore, the gradient of the locus, which is what the perpendicular bisector is the negative reciprocal. Since AB is perpendicular to the locus, so the gradient is actually positive 2. So therefore, locus of Q is just the equation of the perpendicular bisector, y equal mx, and of course m is, we just found m. No, my bad, the gradient of the locus, negative 2 over 1. So the negative reciprocal is actually positive half. You flip and change sign, right? So the locus of Q is y equal mx plus c, where m is actually half, and we get half because AB has a gradient of negative 2, so the negative reciprocal would be half for the perpendicular bisector. And then the value of c, you can always substitute 0, negative 1 in y equal mx plus c, but the value of c, of course, you will see will be negative 1. And you didn't need to do that because 0, negative 1 is on the is negative 1 on the y-axis, which is what c represents, where the graph cuts the y-axis. That's negative 1. So this is our solution. Y equal half x minus 1 is the locus of Q. Same as the perpendicular bisector of AB. Question 5.